Hi everybody, welcome back to the geometry course. We are doing session 11 in this now, and we almost completed triangles. And while triangles has taken some time to do, you should also realize that once triangles is done and the base on triangles is created, I think triangles is around 70% of geometry, because उसके बाद circles और quadrilaterals में उतना new formulas and etc. नहीं आता. Of course, quadrilaterals you have to know all the kinds of quadrilaterals and their areas and their diagonals का properties etc. But the maximum number of content, maximum number of questions also, while as well as the maximum number of theories etc. are abundant in triangles, which is why I'm doing a deep dive in this. And this session is not introducing any new concepts to you. This session we are just trying to focus on understanding how to use similarity in questions, in real-time questions, and how to spot similarity and how to use similarity, and what are the situations under which you should be able to trigger off similarity based thinking in your head. Situations आएंगे तुम्हारे question solving में, in your question solving, where the question will tell you that you should use similarity. So at what points do the question tell you that you should be using similarity etc. is what we'll be looking at through the examples that I've picked up for you in this presentation. So I'm titling this PPT, this session, as more on similarity, and we'll come straight to the questions. Of course, this one is not similarity. ये पहला question है जो आज के लिए मैंने pick up किया है. ये angle bisector theorem पे built है. Angle bisector theorem, if you remember, angle bisector theorem क्या था? The angle bisector theorem was that if you've got a triangle like this, let's say ABC, not an equilateral triangle, let's say, and this is the angle bisector, then x and y, if these are the if this is the ratio of these two sides, then the angle bisector will divide the other side, the third side, also in the ratio x is to y. So that is the basic angle bisector theorem. So इस question में क्या बोल रहा है? If you look at this question, the question says, in triangle ABC, let P be a point on BC. In triangle ABC, let P be a point on BC. So let's do that. Let's say I have a triangle ABC. And let P be a point on BC. And AB is equal to 20 and AC is equal to 10. AB is equal to 20 and AC is equal to 10. So obviously the lengths look different in this, but ठीक है, since we have already gone with that, we'll continue with what the question tells us. And further it says that BP is equal to 20 root 3 by 3 and CP is equal to 10 root 3 by 3. This is 20 root 3 by 3 and this is 10 root 3 by 3. So what is the question asking? The question is asking, find the value of angle BAP minus CAP. The question is asking the value of angle BAP minus CAP. And what should be visible to you if you can spot the angle bisector theorem in this case, that the ratio of this side to this side is 2:1, and the ratio in which the base is cut is also 2:1. 20 root 3 by 3 and 10 root 3 by 3 is a 2:1 ratio. So given this cancellation or this ratio equality, you realize that this must be the angle bisector, and hence the angle BAP and the angle CAP will be same, and the difference between them will be 0. This is the solution to this question. So let's now move into some questions which are built directly on similarity. So the first question is one what you see on the screen. Question says, in a triangle ABC, CD is any line on AB. So let's try to solve this here only. In a triangle ABC, CD is any line on AB. So CD is any line on AB such that angle BAC is equal to angle DCB, is equal to angle DCB. If DB is equal to 18, DB is 18, BC is 24 and DC is 12, we are supposed to find the perimeter of the triangle ADC. So in geometry, whenever you feel or when you are not able to see directly कि what you have to do in the question, जब तुमको directly नहीं दिखता है कि question में क्या करना है, तो in such situations what you should focus on is you should try to look at what is the end result. What is the end result you are looking for? The end result in this case is looking, and this process is called reverse flow charting. That some questions in geometry go this way. You do the first step, you do the second step, you do the third step, you get the answer. But then a lot of questions in geometry, all the tougher questions and all the questions that you will see in exams, all these questions in geometry require you or leave you at a point inside this thinking or inside your solving where you do a first step which is natural and a second step which is natural, and then you hit a wall. And to cross that wall to get to the answer, to the end point of the question, you have to be able to understand what are the next steps, and you many times looking forward you can't see the next steps. So that's when you start thinking from the back and you try to see kya chahiye mere ko. Or since it's in aptitude exam step, the number of questions, the steps will be just 3 or 4 in all questions. If you have done 1 or 2 steps naturally and you can see from the end what is required, so you can try to deflect the question 1 step behind that and then try to see what matches or what is the link between these 2 points, where you are in the problem and where you need to be, so that you can go to the answer. So this process is a very powerful process of thinking in geometry, because ultimately what I'm trying to think you to help you think, or what I'm trying to help you develop is the ability to think inside a geometry problem. Because geometry problem में trigger based thinking तो होता है थोड़ा बहुत, but 90%, 80% of questions require self-generated thinking inside the question. So how do you think in that direction? How do you think in the correct direction of with respect to what you need to construct in different questions, and how do you decide which formula to use at what points becomes a very important aspect, specifically when once all the, I mean अभी जो मैं geometry करा रहा हूँ तुम लोग के साथ, what I'm doing right now is picking up questions where I'm telling you that this is based on this formula. But as you go into your real-time problem solving in geometry, you'll have to identify the segment of geometry it comes from and then the formula it comes from. तो triangle है कि circle है वो तो दिख ही जाएगा, लेकिन कौन सा formula है उसमें? Which is where I told you that you should keep all the formulas visually in your head. तो तुम्हारे पास triangles में all the theorems should be in your head. What is the angle bisector theorem, which is a link between angles and ratios of sides. What is the sine rule, what is the cos rule, सब दिमाग में होना चाहिए तुम्हारे. Right triangles में hypotenuse and that perpendicular from the vertex which is the 90 degrees to the hypotenuse. How does that divide the hypotenuse? All these should be visually available in your mind at any point of time, and they have to be pictures that are embedded inside it, because ultimately when you solve geometry questions, you're going to superimpose what you have in your head, and if you can get the right superimposition into the question, you get the solution. So if you look at, if you can't see what to do in this question, the process to think could be, if I use reverse flow charting, I can think about is that I want the perimeter of ADC. So I want, basically what I want is the perimeter of ADC is AD plus AC plus DC, right? ADC का perimeter चाहिए AD plus DC plus AC. So मुझे AD तो पता है, DC तो पता है कि this is 12, तो मुझे AD और AC निकालना है, और उसको निकालने के लिए the biggest clue is that since this angle is given as equal, angle A in the triangle DAC or BAC, and angle C in the triangle BCD, since these two angles are equal, you try to think about 2 triangles in which a second angle will be equal. And one of the common features of looking for a second angle which is equal is to look for a common angle, and angle B is common in the triangles BAC and the triangle. Now which triangle do I take? BAC has these 2 angles and BCD has these 2 angles. So but which one should I put where? So B is the common angle, so B will be equal to B. So the similarity is basically the angle C here and the angle A here are same, so I'll need to write C instead of A, because when you start spotting similarity you still have to sort it out कि A के साथ D को लिखना है कि A के साथ C को लिखना है. Which one are you writing? Are you writing BAC similar to BDC or BCD? So that's very important, because all your results come after the similarities is put in the correct way. So B is common, so the B angle is same, C angle in this triangle is same as the A angle in that triangle, so BAC and BCD are equal. So now my targets are to find AC. So in this I've got AC, the three equalities, AC upon CD. My other target is to find AD, right? Now AD I'll be able to find if I can find AB. If I can find AB, then I'll be able to find AD as AB minus BD. So AB upon BC, and the third one is BC upon BD. I've got three similarities, three equalities here. So if I look at which ones I know, AC upon CD में मुझे CD पता है 12. AB में मुझे AB नहीं पता है, but I know BC, this is 24. And in AB by BC, let me write it this here, this is 24. And in BC by BD, this is still 24, the third one, and BD is 12, BD is 8. So you realize that basically this ratio of AC by CD is equal to AB by BC is equal to BC by BD. Is all these ratios are basically when you write equality of ratios in a similar in two similar triangles, you say that they are all equal to K, some constant. So once you know 24 and 8, you know that constant is 3. So the value of AB becomes 72. And have I made some mistake? I think BD is not 8, it's 18. I misread that. BD is given as 18. So this multiplier here, or the common ratio, is actually 1.33. 4 by 3. So if this is 18, this is 24, this is 24, this will be 32. And if AB is 32, then AD is 14. ये मिल गया. अब मुझे AC पे फोकस करना है. CD मेरे को पता है 12 है, CD पता है 12 है, और CD अगर 12 है तो AC 16 हो जाएगा. Just remember that the ratio is constant at 4 by 3 everywhere. So you use the multiplier logic of the ratios here. I'll just explain that once more to you. This whole process once more to you. Anyway, आंसर क्या आ रहा है पहले वो देख लेते हैं. मेरा AC का वैल्यू 16 आया और AD का वैल्यू 14 आया, तो मेरा 42 आ रहा है वैल्यू. ADC, AC is 16 and AD is 14. So 42 is the value that is coming out. Let's just see this again. इसको फिर से देख लेते हैं, so that you have clarity about the thinking process here. The thinking process, I mean, देखो जब भी दो triangles में तुमको एक angle से equal दिखता है, तो you immediately have to start thinking, and specifically if you are trying to look at some lengths given and some other lengths asked, so you have to think about similarity in such cases. So the starting point becomes that, okay, angle C here and angle A in this is equal. Well, that's the trigger in the question. So angle C and angle A, angle C in BCD and angle A in DAC, or in BAC, either in DAC or BAC. Angle A is in both of them. It's there in DAC also, it's there in BAC also. So angle C and angle A are equal, and then you see that the angle B in BCD is common to the angle B in BAC. So then you know that BCD and BAC are similar. और BCD और BAC सिमिलर है, तो तीन इक्वालिटीज ऑफ थ्री रेशियोज आता है. BC अपॉन BA इज इक्वल टू BD अपॉन BC इज इक्वल टू सी डी अपॉन ए सी. स्टार्टिंग में जब तुम बहुत यूज टू नहीं हो to writing to solving similarity based questions, you've not done too many, then you first write all of them, right, in the question, and then you start seeing this is equal to k, some constant k. So then you start checking which one of these is giving me or which one of these values is given to me. So when I start looking for the values, I see that BC is given to me as 24 by the problem. BC is given as 24 by the problem, and AB is something I have to find out. I don't know AB, right? Then BD is given to me as 18 and BC is given to me as 24. तो अगर ये दोनों मुझे पता है 18 by 24 3/4, तो ये भी 3/4 होगा. या तो ऐसे भी निकाल सकते हो 24 into 24 by 18 BA का वैल्यू आ जाएगा. सॉरी BA का वैल्यू, या BA उधर ले जाओगे तो BC²